This is part two of investigating how we can compare different compounds and decide what sort of relationship they have, whether or not they're isomers or whether they are identical. So in the previous video, we reviewed this chart. And so remember that isomers are different compounds with the same molecular formula. There are essentially two ways that this can happen: structural isomers or stereoisomers. Structural isomers will have a different four-part name because they have a different attachment of atoms. This should be the first step in comparing two compounds. Do they have different attachment of atoms? If they do, stop there. They're structural isomers. But if they have the same attachment of atoms, but a different arrangement in space, they might be isomers either of the enantiomer sort or the diastereomer. Remember that diastereomers are essentially stereoisomers that are not enantiomers. Enantiomers have a very specific relationship in that they're non-superposable mirror images. So I'm going to look at two other examples in this video. The top example here, if we start or think about our chart, we ask ourselves, do these two molecules have a different attachment of atoms? And as it turns out, they have the exact same attachment of atoms. If we consider whether or not they're stereoisomers, well, clearly they're not the diastereomer sort of the EZ type. Well, then potentially they could be enantiomers. But then, for our purposes, in order to have non-superposable mirror images, we need to have a chiral center. If you look carefully at either of these two structures, neither of them have a chiral center. And so, in fact, these two structures represent one single molecule. One of the things that you could think about is if you take the molecule on the right and if you were to rotate it or flip it completely, then it would superpose perfectly with the second molecule. So these two structures are identical. In comparing the bottom two molecules, one of the things that you'll notice is that they have the exact same attachment of atoms. But this case is different in the sense that we do have chiral carbons or chiral centers. The chiral carbons and chiral centers are found here and here. Now these are chiral because four different things are attached to these carbons. There's a hydrogen going back in this case, and there's a hydrogen coming out of the plane in this case. Now we could go to the trouble of assigning R and S, and we would indeed find that they have opposite absolute configurations. But there's another way to quickly identify that indeed these are enantiomers. You may notice that everything's the same in terms of the bonds that are in the plane of the screen. The only difference is that the methyl group in one example is coming out at us, and the methyl group is going back in the other case. So essentially, the methyl group and the hydrogens have been changed or switched. You may remember that anytime we switch any two groups about a chiral center, you end up with the enantiomer. So these are, therefore, enantiomers. I hope you have found these two examples helpful in reviewing the concept of looking at pairs of molecules and deciding what their relationships are.